Good day everyone. I welcome you to Silas Academy. This is my channel. Please do it to like, share, and comment on this video. Today I'm going to be teaching about KIRCHHOFF'S law. Now what is KIRCHHOFF'S law? When you are talking about KIRCHHOFF'S law, you are talking about what? An analysis which helps you to what? Resolve or solve equation under what? Electric circuit. Are you following now? It teaches you how to what? Solve any equation concerning electric circuit. Now, under KIRCHHOFF'S law gave birth to two sons, which are what? The current and what? Voltage. KIRCHHOFF has two divisions, which are the what? Current and what? And the voltage. Now, each of these guys have their own laws. Are you following now? KIRCHHOFF gave birth to this one, and this one has its own law, this one to have its own law. Now, what does this one law state? Now, having this law, you have what? Your KIRCHHOFF's current law, which is also known as what? Your KCS. KCL. Now, what does this law state? Having this law, it states that what? In an electric circuit, the algebraic sum of current entering a node is equal to what? The algebraic sum of current leaving the node. Now, let's write. KIRCHHOFF'S law states that in an electric circuit, the algebraic sum of current entering the node is equal to the sum of current leaving a node. Now, mathematically, it is being expressed as what KIRCHHOFF writes. Now you say the sum. This is what? The symbol for sum. Abina. Then when you are talking of current, it means what? I. Means what? Your I. Entering inside the node. This I. Ni in Abina is equal to what? Sum of current going out. This is my mathematical expression of what? KIRCHHOFF'S law. Are you following now? Okay, now, having this thing like this, diagrammatically, how are we going to express or explain this thing? Now, in a node, let's take this point to be a node. But the law states that the algebraic sum of current entering the node is equal to the current leaving the node. Abina, let's take this point to be a node. Now, have something like this. You have something like this, and you have this one like this. This is your point of node. Let's just say each of these things is 1, 2, 3, 4 here. There are 4 entries. Are you following now? Having your arrow again to point outside is 1, 2, 3, and 4. You see that what? The ones in which the amount is entering inside are 4, and the ones which their current is going outside is what? 4. So therefore, we are going to see that what? The sum of current entering inside this node is equal to the what? Sum of current leaving the node. Let's do something like this. To show that it's what? It's current. This is what? The diagrammatical expression of what? KIRCHHOFF'S law. expression of Kirchhoff's law. Now, I told you in other first class that node is a point in which two or more components have been what, connected or joined together. Hopefully now, having this circuit here, where is your node? Know that two or more components are what, joined together, that meet at a point. So this one will be your node. This all these points are what, your node, because this is a point where this one, the current is entering, this one too is coming, this one too is entering, having a, so that is your node. Okay, now having a circuit like this, how are you going to analyze the circuit? How are you going to solve this type of circuit? Now, analyze the network using the what? Kirchhoff's law. Hopefully now, using Kirchhoff's law. Okay, now, I've already told you the steps using what? Solving Kirchhoff's and voltage law in our first class. Hopefully now how do you solve this circuit? You redraw the circuit down, apply your current on each node. Hopefully now, secondly, you would draw or insert your what? Mesh current. You know, at this point here, I call what? The meshes. So what? Redraw and what? Identify your mesh current. This to show that what is going in what? Clockwise what? Direction. So you see this mesh 1 and is in current, you call it what? Your I1. This what? Your mesh 2, you call it what? I2. Are you following now? These are mesh. Now applying the current in things like this. This will be your what? I1, I3, and what? Is going down. I2. Now let's solve this circuit. Solution. You see, applying the KVL rather, in loop 1. Loop 1 or mesh 1, they are the same thing. Are you following now? How do you apply the KVL as the Kirchhoff's voltage law in solving this question? This one is moving in this direction. Are you following now? Since it's going in this direction, I'm going to see minus 10 plus these 2. I'll be now, let me see, 2I1. Why is it I1? This I1 is what? Attached to it. Are you following now? So I'm going to say what? 2I1. Then since it's for the first loop or for the first mesh, this is the one you are dealing with. You come now to this point, you see what? Plus 3 into I1 minus I2. Why is it I1 minus I2? I1, this is it. Are you following now? But since it's for the first mesh, this 3 is sharing the first mesh and the second mesh. So you have what? I1 minus what? I2. All is equal to what? 0. Don't forget what I told you about Kirchhoff's law. That what? The sum of what? Voltage are equal to what? 0 from our first class. Now, since all of them are equal to 0, that's why we are having 0 here. Now, how can we analyze this? You simplify by what? Opening your bracket. Is minus 10 plus what? 2I1 plus 3 times I will give you what? 3I1 minus is equal to what? 0. Open the bracket, you have something like this. Now I'm going to collect like terms. There's I here, there's 2, and there's a normal integer here. I'm going to say minus 10 plus 2I1 plus 3I1 will give you what? 5 I1 minus 3I2 is equal to what? 0. Watch closely. You are trying to get what? A simultaneous equation here. Now, when you rearrange this thing, you have what? 5I1. 1 comes before 2. You are going to say 5I1 minus 3I2. Abina, this minus 10 crosses this equal sign, changes to what? To equal to 10. You call this your equation 1. Are you following now? Call that your equation 1. Okay. Since you have gotten the equation for the first mesh, you use the second mesh now. You see, applying KVL in loop 2. Loop 2 is for this loop now. So I'm going to start from what? This voltage here. Remember, here we started at what? This voltage. So for the mesh 2, we are going to start from that 12. We are going to have what? 12 minus that 3 here. The 3 is sharing between what? The second mesh and what? The first mesh. At the first mesh, we had what? We had 1 minus 2. Abina. So this one will have what? 2 minus 1 because we are solving for the what? Second mesh. Now, plus that 4 here. 4I2 is equal to what? 0. Now, how do you solve this? Use the same process there. 12 minus 3 times I2 will give you what? 3I2 minus, okay, minus times minus turns to what? Plus. You have 3 times I1 gives you what? 3I1 plus 4I2. All equal to what? 0. You would collect your like terms, then you simplify. You have 12 minus this minus 3I2 having a plus 4I2. All of them are having what? Coefficient of what? I2, I2. So minus 3 plus 4 gives you what? Minus 1. So you have what? Minus I2 plus 3I1 is equal to 0. Now, you rearrange. Rearranging this 3I1, 1 comes before 2. You take it by saying 3I1 plus what? 3I1 minus I2 is equal to what? This 12 crosses this equal sign, changes to what? Minus 12. This gives you what? Equation 2. I play now. So now I'm going to solve to get what? The current in what? Mesh 1 and what? Mesh 2. How can we solve to get the current in mesh 1 and mesh 2? We are going to use what? The Grammar's rule. Now, how are we going to apply the Grammar's rule on this type of equation? We have what? 5I1. 5I1 minus, okay, now let's bring the equations together. 5I1 minus 3, 5I1 minus 3I2 is equal to 10. That is for the equation 1. Yeah, we'll say bringing the equations together. The equations Bringing the equations together. Now this for the equation 1. Take your equation 2 to be what? 3i1 minus I2 is equal to what? Minus 12, which is equation 2. Now, to get the current, I'm going to what? Say using the Cramer's rule. How do we use Cramer's rule to solve this type of equation? Find your determinant. This is your 5, 3. That is for these ones. Now coming to this side, you have what? Minus 3 and what? Minus 1. We are finding current 1 and what? Current 2 are equal to what? 10 and minus 12. How do you solve this? You find the determinant of this matrix. That is equal to what? This diagonal, you multiply each of them. Then minus from what? This other diagonal. By saying 5 times minus 1 minus this diagonal now. That is 3 times minus 3. I follow now. That is this one here. This one times this one minus this one times this one. Abina. I will say 5 times minus 1 will give you what? Minus 5. Bring your minus sign now. Minus 3 times 3 will give you what? Minus 9. Abi. I will say 5. Minus times minus gives you what? Plus 9. 5 minus 9 gives you what? Minus 5 plus 9 gives you, to give you minus 4. Sorry, it needs to give you 4. And 4 becomes what? Your determinant for this matrix. Now, in finding your I1, you are going to what? Remove, now take it at this what? Your I1 and what? I2. So replace, remove this one, bring this one, put it, and remove this one, take it to the other side. How are we going to do that? Now, the determinant of I1 now becomes to be what? Now I'm going to use this one now. That is 10 minus 12. Put this one, you have what? Minus 3 minus 1. I follow now. Bring back the current 1 and current 2. Is equal to what? Now, since you have replaced this one here, you are going to put this one back. So bring it here to be what? 5 and 3. Are you following now? Okay. Take the determinant of that matrix. That is 10 times minus 1. You have what? 10 times minus 1 minus, the other diagonal gives you minus 12 times minus 3. How are you going to solve this? 10 times minus 1 gives you what? Minus 10. Minus 12. Minus times minus gives you plus. 12 times 3 gives you what? 12, 24, 25 plus 2 times, okay, 3. You have your 6, you have your 3, that is 36. You have what? Your 36. Is minus 10 minus 36 gives you what? Minus 46. Are you following now? This for what? Your depth of I1. Now, let's solve for depth of what? I2. Bring back what? The determinant again. Now remove that one. Keep 10 and minus 12. Remove these ones now. Replace it with these ones. We are going to have 5 and 3. I'm going to have what? Your 5 and 3 like this into what? I1, I2 is equal to what? Carry this one I remove, put it inside, which we are going to have 10 minus 12. Find the determinant of this one also. That is this one times this one minus this times this. That is 10 times 3 minus 12 times 5. Are you following now? Okay, now how are we going to solve this thing like this? 10 times 3 gives you what? 30 minus 12 times 5. Minus 12 times 5. 5 times 2 gives you 10, right? 0 carry 1. 5 times minus 1 gives you minus 5. Plus 1 gives you 6. That is 60. That is minus 60 rather. Minus times minus gives you plus. But is equal to 90. Don't forget what you are finding. You are finding what? The current for current 1 and current 2. In getting your current 1, you are going to say the determinant of I1 but all over your real determinant. Determinant of 1 this one, but when we solve this one we got it to be what? Minus 46. So you bring it to minus 46 all over the real determinant is what? 4. Why for now? The real determinant gives you what? 4. Now what is your final answer here for the I1? I will say minus 46 divided by 4 gives you what? Minus 11.5. That's for your I1. Now I2 is equal to what? That I2 minus your real determinant. Your delta 2 is what? 90. That is 90 divided by your real determinant, which is 4. So 90 divided by 4 gives you to what? 22.55. And this becomes what? Your current for I1 and I2. So I1 is equal to what? Minus 11.5. I2 becomes what? 22.5. This becomes what? The final answer when you solve what? This network using what? KCL and finding what? The boot current. Guys, don't forget to like, share and comment on this video. Subscribe to this channel so that what you follow up my next video on what? The KIRCHHOFF'S law again. Thank you guys for watching.